90% of students get the simple SAT question wrong. Can you get it right? Okay, so this question looks like it has a lot of information to take in, but let's analyze what it actually says. So you have two squares sitting next to each other, and the larger one's side length is 3 times the smaller square's side length. For now, let's set the smaller square's side length as s, so the larger squares would be 3s. A uniform electric field with a strength of 29 volts per meter passes straight through both squares, and the total electric flux through the entire surface, so both squares combined, is 4,640 volts times meters. And we have to find how much of that flux passes through the larger square alone. Well, to do this, we have to know how to relate the electric flux to the electric field and the area. In the question, it says that the electric flux is in volts times meters. It also says that the electric field is in volts per meter and the area is in square meters. So, the formula to find electric flux is electric field times square meters, or flux equals field times area. Because we set the smaller square's side length as s earlier, the smaller square has an area of s squared. And since the larger square's side length is 3s, its area is 9s squared. Since there are two squares, one with an area of s squared and one with an area of 9s squared, the total area of these squares would be s squared plus 9s squared, or 10s squared. This means that the total flux is split into 10 equal parts. 1 part for the small square and 9 parts for the large square. And since the total flux is 4,640 volts times meters, the flux of 1 part is 4,640 divided by 10, or 464. And since the larger square gets 9 parts, we can multiply the 464 by 9 to find that the electric flux through the larger square is 4,176 volt times meters. For more tips to solve real SAT problems, make sure to subscribe to my channel.